The next one is exponential distribution. So, for example, there are certain variables whose value decrease much faster, or they are decrease in proportion to their current value. So, like electric lamps, say X is the life of an electric lamp measured in days, and say it is 500 days. To calculate the probability associated with it, we need a PDF for it, and this is how it will say the life expectancy is deteriorates, right? It never goes to zero, but it falls pretty quickly. So this is a about 365 days, and if it this is the probability of its dying, and if it dies after 355 days, then the company said that they can replace it because they warranty it that it will last at least 1 year. Okay, so f of x is the PDF, and we want to know the PDF or probability of x more than 365 days. So that is 365 infinity fx dx. So then there is, you need to have a formula for the PDF of exponential distribution. So f of x for an exponential distribution is 1 over lambda e to the power minus x upon lambda, where lambda is a positive constant, but lambda is the average lifespan, where lambda is the average lifespan. So if average lifespan is 500 days, then you just put here in a differential, in a integral 365 to infinity 1 upon 500 e to the power minus x upon 500, and that will give you e to the power 365 over 500. So that is the probability of no loss to the company, because if it is dying after 365 days, there is no loss. Now this here is the formula for the exponential distribution. Here important is a lambda is an average lifespan. In certain places we have lambda written as 1 upon average lifespan, and in those situations the formula will become fx is equal to lambda e to the power minus x lambda. But if lambda, we counting as lambda as average lifespan, then that will be the formula for the exponential distribution. Now we can do some questions on it. So the question is, so this a question is a laptops produced by a company X, Y, and Z last for an average of 5 years. Lifespan of laptop, so they have to tell you this in the question. Lifespan of laptop follow an exponential distribution. Now we calculate the rate parameter. Now rate parameter, if you call it a rate parameter, then this lambda will become 1 by 5, that is 0.20 years. And now if we want to know the PDF, which is f of x, that is going to be 1 upon lambda e to the power minus x upon lambda, so that is going to be 1 upon 500 e to the power minus um, x. If x is whatever number it is, if it's x is 3, then it's going to be minus 3 upon 500. So that is going to be your PDF of it. So this is just, and then you just calculate that thing depending on what you want it to be. Um, so it depends on what we want to call this lambda as. This little thing here um, is 1 upon lambda, and that is 0.20 depending on the source. For so now the question is, what is the probability that laptop will last less than 3 years? So now you see this thing here, and we have this as a 0.20, and it is 0 and 3, and we need to calculate the area to the left of 3. So probability of x being less than x is going to be 1 minus all you will do here is to integrate the probability lasts less than 3 years is 0 and 3, so you will do this integration from 0 to 3, and you will write 1 upon lambda e to the power minus x upon lambda dx, and that will give you the answer. And that will be the same for if they ask for more than 10 years, then you would write 10 years and the infinity here, and then just the PDF here, and use the integration to get the answer.